All right, great. Um, so, like I said, welcome. This is the Alaska Energy Training Group. I think this is our fourth meetup. We're a group of energy professionals really throughout Alaska's training, troubleshooting, technical assistance, and broadly workforce development fields, with the shared goal of improving coordination and collaboration, and really accelerating, this energy transition, and making sure we're doing a good job maintaining our infrastructure and working together. Um, and we work really across regions, and across industries. Um, we've had discussions in the past that straddle, um, water and energy infrastructure for monitoring and maintenance tools, that touch on training practices in both larger natural development companies and smaller diesel mechanic shops, and other collaborative topics like today. And the group, just for some background, is a shared initiative facilitated by REAP, Renewable Energy Alaska Project, and in close collaboration with the Denali Commission. It's really open to all related partners and ideas, really just to help de-silo our work and spread best practices and, accelerate our work. So personally, my name is Jenny Stars. I work for REAP, like I said, Renewable Energy Alaska Project. I am the program manager for our Energy Education and Employment Network, which is another acronym, ANNE. And Annie's longtime director, Chris McConnell, who's been deeply involved in this group, recently moved over to AEA to head up their rural programs, which we're pretty excited about. Also hoping to rope him back in, as much as we can in the future with his important role over there. But he, will not be joining us today as he has been in the past, due to that new role. And personally, I am joining from Anchorage on Denali lands. And it would be great to hear from all of you, with your introductions in the chat. There's so many of us. I think that'll be the most efficient way to do it. So if you could share your name, organization, location, whatever else would be helpful for this group to know, that would be great. And I'll share that in the chat too. Great. And so while those are rolling in, I will introduce our agenda for the day and our esteemed panelists. So we'll have presentations on heat pumps from our experienced panelists, Phil Kaluza and Dr. Diana Fisler. And then we'll have some time for questions and discussion. If questions come up during the presentations, please drop them in the chat. And then if we can't address them in real time or right after the presentation, I'll keep track of them so we can get them answered in the main discussion. And then at the end of our meeting, we always try to save a little time for you all to share updates, whether on the topic or just general training and technical assistance, progress and projects. And I'll also share our next meeting time. So to get into it, like I mentioned, our topic today is heat pump technology in Alaska. I promised I'd try to give my sort of intro to heat pumps in a very non-technical way to save Phil and Diana some time to really dive into their specialties. So my non-technical explanation, heat pumps, really powerful tools for decarbonizing homes and buildings. They're essentially a refrigerator or a reverse refrigerator, using electricity to run a compressor and then moving heat into our indoor spaces. Crucially, they're much more efficient than other electric heat systems, and often more than furnaces and traditional combustion systems, and can be more economical if you're flying in and buying expensive heating oil to switch your heating to electricity or part of it. And what we're going to be focusing on today is really heat pumps in Alaska, the technology for cold climate heat pumps, which enable them to operate efficiently in cold temperatures, is improving a lot. So we'll learn about that a bit today, but also about, the considerations and lessons learned from Phil and Dr. Fisler. Um, and that's really top of mind right now, with the many incentives and grant-funded projects for heat pumps, the Inflation Reduction Act's tax credits, the state's home energy rebates that are slated to be rolled out in the next year. Those cover heat pumps. And then there are larger initiatives like in the Northwest Arctic Borough and in coastal communities through Southeast Conference and Alaska Heat Smart to install thousands of heat pumps, as well as programs working to train installers and auditors and technicians and all the people needed for these technologies. So it's really timely time to discuss these things. So to transition to our panelists, we have two seasoned pros joining us, Dr. Diana Fisler and Phil Kaluza. We're going to start with Phil, who has installed and serviced a number of heat pump systems in the Seward area where he's based. And he's gleaned some really helpful insights into best practices, especially for installation and maintenance during that time. So I will pass it off to Phil and keep an eye on the chat. Phil, can you share your screen okay?
I lost it. Where'd it go? Where'd it go? So yeah, again, I'm Phil Kaluza down here in Seward, and about 8 years ago, retrofitted a little house and bought my first air-to-water heat pump and installed that, and it's able to heat my house using some radiant floor heat I put in. And I also, it's a little duplex, so I also bought a mini split, an air-to-air heat pump in my apartment, and I've been monitoring those for the last 6-7 years. So got some really interesting data to kind of share on that at some point in time. But I think this session, I just wanted to talk a little bit about last winter. We had a serious snowy winter, and we had a few problems with our heat pumps that I think we need to address on the installation side. So I need to find out how I get to share.
Yeah, so if you're on the Zoom screen, it should be the share button in the middle at the bottom middle. There you go.
There we go. So I really want to talk about the outdoor world in terms of heat pumps, but in terms of the indoor and where you install them, I guess the one issue is the little bit of maintenance. There is a fine screen in those indoor, what we call heads, that just like your refrigerator coils, the old refrigerators anyhow, you have to clean those. And that's between cleaning the indoor screens and the coils on the outside, that's pretty much all a homeowner can and should do. So unlike your oil heating systems where you have tune-ups and other issues that may require, professional service work, as long as your heat pump's kept clean, you really don't have a whole lot else to attend with. So what we found last year, we had a really heavy snow year. Lots of times we get melts and it goes away. Last winter, it just kind of kept building. And here's kind of the world. This is common sense. These outdoor units don't like to be in snowdrifts and they don't like to be under waterfalls. So if we can address those issues, I think temperature really is not until you get down to 0 or colder. Temperatures really aren't that big of a deal. I was kind of excited up in Fairbanks. They ran a heat pump down to 42 below till it finally stopped working. The refrigeration cycle just said, "That's it. I'm sorry, we can't vaporize this refrigerant anymore. We're done." and it automatically came back on when it warmed up 10, 20 degrees. So that was kind of interesting. So it's not so much the temperature for the milder climates, it's just kind of dealing with the rest of this stuff. So this is a neighbor who had this underneath his overhang for a number of years, worked fine, and now with this heavy snow, and we all kind of know all that snow likes to curl up underneath, your overhangs if it gets really thick. And so this poor unit, ran until it just couldn't run anymore. It ended up burning out the fan motor and the circuit board. And it was just between the water dripping, it's on the south side of the person's house, and between the water dripping from the sun shining on that side and snow accumulating, pretty much just clogged up the entire coils in the side and the back, and caused some damage. Unfortunately, the warranty covered parts, but it was still hundreds of dollars to replace all of that. So my air to water heat pump, really it's essentially the same as a mini splitter air to air heat pump, but instead of making warm air through a fan coil on the inside, this basically preheats water in a tank. Well, I was getting this drip on my unit. It's under a nice overhang. It really doesn't have a problem with snow gathering on it, but this drip would splash behind this unit. And you got to remember, these coils are significantly colder than the actual outdoor temperature, and that's how this magic of refrigeration works. That's able to still absorb heat. Well, it would suck that splashing water, and I ended up with a big icicle running down the back of my unit, which in itself wouldn't have been the worst case, but it just happened to cover up an outdoor temperature sensor that was installed in the back. And for whatever reason, it convinced the unit it didn't need to defrost, and it just kept building and building and building. Well, it was kind of like, okay, I ran into the shop and grabbed some scrap wood, basically just made a little slope roof. So I wanted, the water can drip off the front and the fan will blow it away. You just don't want water dripping down the backside of your unit. And so even something this simple will help a lot. And then it was like 2-3 weeks later, this mini split for my apartment, it's been going for 6 years and never had an issue. Well, the gutters were full, the snow was packed up on top, and I ended up with that drip again on this unit. And it doesn't freeze up the coils. The defrost part of the units, when they sense they need to defrost, they warm up those coils. They actually circulate warm refrigerant, kind of reverse the cycle. It's in kind of a cooling mode now. And so the coils become clear, but you end up with this sheet of ice on the outside blocking the airflow. And obviously, if you can't get air flowing through there, you can't extract heat, and the compressors are working hard and not accomplishing a whole lot. So again, back into the shop, a scrap piece of plywood and some 1x4 that I cut diagonally, and a couple little blocks for spacing, and that pretty much eliminated that problem. This is probably the biggie for a cold climate. And so this is my unit right before it's ready to go into defrost mode. And most people, when they see this, think their unit is dead. Something is terrible. It actually amazes me how much heat you're still extracting, even though it's this frosted up. But then at some point, the unit goes, okay, temperatures aren't quite right, something, I need to defrost, reverses the cycle, melts all of this frost. Well, all this water has to go down a drain, a hole in the bottom of this unit, and go away. Well, when it's 10 degrees outside, 20 degrees, anything below freezing, that water just wants to refreeze again. And so if you happen to have a sidewalk or something in front of this unit, so whatever direction gravity wants this water to flow, because the ground's frozen, it's not going to go into the ground. So you just have to think about this. This is kind of the reality. You know, it's just like an old refrigerator that needed that little freezer compartment defrosted. Just, you have to deal with that water and that ice. If your stand is too low, that water will just, that ice will turn up into a big mound of ice and actually can grow to the point where it's blocking that drain and it'll no longer drain. And then the bottom of this unit starts filling up with ice until the fan starts hitting that ice, because there's only about an inch or so of clearance on the bottom for that fan in the front. And it starts clinking, and pretty soon things go haywire. So just figuring out how to deal with that makes a lot of sense. I added pan heaters because in Seward, I don't believe it's really that cold or cold enough that there's an issue once you melt this frost of this water being able to drain out and get outside of that unit. Now, as we get in colder climates, that may become more of an issue. But in, Seward and Southeast, I don't think pan heaters are as big of a deal. It's more of an insurance policy. But the problem is the pan heater is really like, it's got a coil, a heating coil on the bottom. So you're essentially heating the grate out of doors for, 5, 10, 20 minutes after each cycle, which is kind of a shame to be heating the outdoors, but a good insurance policy, I guess. What else we got here? So this is kind of a fun project. A lady that I know that lives in this old log house. And so we put this little mini split there, which doesn't quite do the job, works hard all winter long, frosts up a lot. And so originally the story is I basically cut a nice hole underneath her deck because that drops down about 4 feet to the ground. The heat pump's really happy. It's covered. It's not dealing with driving rain, snow, any of the elements. It just gets plugged away. But I cut this hole in the deck and that froze up. Things started icing up on her deck. I cut a bigger hole. I made a funnel. I was doing all kinds of things to try to get that water just to get underneath the deck. Eventually, I had to go underneath and cut out a section of that decking that she had there to make sure that water flowed out. But I know people try to hook up a hose to the bottom, which it comes with adapters to hook a hose to drain, but I think we all know what happens if you got a long hose and a drip of water. That drain line is just going to freeze and the water is going to back up and we're back into the problem mode. Accessibility, we do have those coils on the back that need to get cleaned occasionally. I find because we generally only use them in the winter time, there's not a whole lot of stuff in the air to clog these things up. But if you happen to run your heat pump as an air conditioner summer and the cottonwoods are doing their magic, you can clog up those coils, and we need to clean them on occasion. Got to keep an eye on them. So covers, overhangs are nice, but they're so high up that things happen. So there's lots of options in terms of just building a nice little cover of some sort. I guess I just got to remind people that the circuit board is on top, so you have to be able to take the top cover off these heat pumps to access the circuit board and do some service work. So you have to kind of keep that in mind in terms of how they're going to get to it, or if you can remove the top sort of thing. I kind of like this, other than I wished it was a little higher up. Seems like it's got good, circulation potential and stuff. Looks fairly nice. I just think if this thing was moved up a little higher, and again, every now and then Could it be only every few years you want to get back there with a vacuum cleaner and a little brush and clean up some of the stuff that's accumulated on the coils? So if you could make this so that you could easily take the sides off to get at the coils, I think that would look very nice. You can see this homeowner is just kind of, it's part of the routine of keeping the snow away from it. I guess as long as you're on it and that big storm doesn't get ahead of you, I'll be okay. A lot of prefab sort of covers and stuff, but again, circulation of air is very important. That fan is moving a lot of air through those coils, and so you don't really want to be restricting it too bad. But again, the idea is trying to give it some protection. Here's my sister's house in Minneapolis. We put 2 of these little heat pumps in. This was like four years ago, and we could not find a heating refrigeration company, hundreds of them in Minneapolis, to install mini splits. They all wanted to put central cooling in this 1890s house, and she just wanted a little cooling in her living room and a little cooling in her bedroom. And so we put in 2 small units. One went up to her bedroom and the other one took care of the living room area. And her neighbor friend was a carpenter and built her a nice roof. Doesn't get much better than this for a heat pump in a cold climate. The other little concern I had when I first put in mine was how much noise comes from these units. And I actually had put mine in I had to run it a ways because of my neighbor's house was very close and I was concerned about sound. Well, kind of turned out they're pretty darn quiet, especially in the wintertime when windows are all closed and neighbors are fine. And this is a very convenient bracket system for holding up these heat pumps, because you can put them as high as you want and still be able to, not too high that you can't service them, but you can certainly get them far enough off the ground. But there is some vibration that goes through these brackets. So I would not be installing this on a bedroom wall. Living room, well, maybe not so bad. As long as the TV or radio's on, you never hear it. But kitchen walls, garage walls, exterior walls, all of that, I think is fine. Just definitely stay away from bedroom wall, because you would hear it making that noise. So I guess I wanted to leave the rest open for questions later on.
Perfect. Yeah, that was so much great information, Phil.
Now I got to get out of this.
Yeah, so if you go, there you go. Yeah, yeah, thank you so much. Alyssa asked a question in the chat, but I'll save that for the end. And I think you could also see some of the brands in some of the photos, and we'll try to share that those slides too. But I want to make sure we have plenty of time for Dr. Fisler. So Alyssa, I'll save your question for the discussion at the end, but it's a great one. So now to move along to Dr. Fisler. So Dr. Fisler is a material building scientist. She's also the founder and CEO of EcoSnap. That is a company that has developed a heat pump that has a different new ductlet installation process attached to it, I guess, really to target the issue that Phil mentioned, having in Minneapolis, and that I've heard in South Central as well, about just struggling to find installers. So Dr. Fisler, their company is also in the Launch Alaska portfolio, and she'll be sharing about their demonstrations in Alaska and some of their upcoming goals. So I will turn it over to you.
Great, thank you so much. Can you guys hear me okay?
Yes.
Okay. Thank you very much, Jenny, for the introduction. So I'll talk a little bit about the genesis of our company, and then as Jenny said, I'm going to tell you a little bit about some funded projects that we have going on that are directed toward the Alaska market. And I'd love to get your feedback. I already got some great ideas from watching what you shared, Phil. So, nothing is changing. There we go. I'm going to talk about what problem we were trying to solve when we formed this company and exactly how the EcoSnap solution works, and then I'll move into the grants that we've won that we're working on starting now and in the next month. So the problem that alerted me and frustrated me was I had an office, a home office, and it was the classic case of too hot in the summer and too cold in the winter because it's at the end of a duct run. We have a forced air gas furnace. And when you ask people, I swear that everybody who has ducted heating in their home says that they have a space like this. And, you know, there are solutions to it, but they're not ideal really. And so I found out about ductless mini split heat pumps, and I kind of fell in love with the idea because of the efficiency, the idea that you could have, you know, under nominal conditions like 300% efficiency or more, and you could get heating and cooling, and it's just seemed to me to be an ideal solution. And I couldn't understand why everybody wasn't doing this. And then I found out the problem. And the problem is that the way that they're installed requires multiple trades. It has to be wired to the electrical panel, and an HVAC technician is required for handling the refrigerant lines. And you know, if you're lucky enough to find an HVAC technician in your area, as Phil pointed out, in Minneapolis, they couldn't even find one. And I know in rural Alaska that there's no HVAC technician to be found. So even here in Colorado, where we do have lots of these trades, you can receive a quote easily of $4,000 to $7,000 to install a single mini split, and I've even seen quotes of $10,000 for just one of these units. And so that to me looked like a market problem that could be solved. I was like, that there must be a way for us to use clever engineering to design around this and to allow for everyone to be able to access efficient heating and cooling. So I kind of went on a mission to try to solve this problem. And, you know, I should point out that in other parts of the world, in Asia and the Middle East, this is not a stopper. Lots of people have mini splits. So I knew that the technology was available, and I felt that I could solve the problem of accessibility. So what we identified is that there was technology available from NREL here in Golden, that's the National Renewable Energy Lab, that basically pre-charged the systems and created a way for the refrigerant lines, the electrical and the condensate line, all to be connected with a simple lever. And I'm going to show you another close-up picture of it there, in a minute. But this lever here is located inside the outdoor unit. The air handler and the condenser are co-located through the wall and rigidly attached. And there are consequences to this design. One is that the condenser will be mounted high on the exterior wall, which, as we've seen in Phil's presentation, will protect it actually from snow buildup and other problems. But it's a one-to-one solution. But essentially, it allows you to avoid having to handle refrigerant, and it reduces the time and cost and hassle of installation significantly. So I'm not going to talk anything about incentives and rebates right now, but we can get into that if you want to a little bit later. But if you look here to the left, there's a lever. It brings two housings together that quick connect refrigerant couplings, condensate and electrical. And the electrical is actually rerouted toward the interior so that it can plug into an outlet. And so that eliminates the need for an electrician as well. Moving on, the other consequence of this that it's just an installation technology that can be applied to any commercial mini split that is available. And what that means is any performance that is out there can be installed this way. And what we've been able to find is a very good performing cold climate heat pump that is on the NEAT list. That's the Northeast something or the other energy performance list, which means that it's got a COP at 5 degrees of 2.1, which is still pretty good. It's 115 volts. We can offer capacities of 3/4 to 1 ton. Bigger than that starts to get too heavy to hang on to an exterior bracket, and it really doesn't make sense to have a single point above 1 ton or maybe like 1.5 tons. And so basically even if something with better performance came along, we could just apply the technology to a very good performing cold climate mini split. This is the consequence of doing this kind of connection technology broken out by all of the steps that are in a traditional install. And typically I hear HVAC installers tell me that, you know, an installation of a single mini split takes between 6 and 8 hours. And that's why it costs so much, because they've got to get out to your house. They got to spend 6 to 8 hours there. They need to fabricate the refrigerant connections in the field, charge the refrigerant, evacuate the lines, cover the line set. And we remove all that with this drilling of a hole and the throwing of a lever. And it brings the installation time down to 1 hour or less. So that's the technology, that's the solution, that's our company. And I want to talk to you a little bit about a couple of grants that we're working on right now. And I would love to have participation questions, criticisms. You can throw things at me, whatever you want. One is a small SBIR, that means Small Business Innovation Research Grant through the Department of Energy, where we're going to develop an interoperable thermostat between a Toyo stove and our EcoSnap mini splits. And so the premise here is, you know, a mini split may work down to minus 42, like Phil was telling us, but it starts to get a lot less efficient at really low temperatures. And so you're at you know, maybe at minus 20, your electricity bills are going to start to go up. And so at that point, you want to switch over to the oil stove, and to get the right economic balance, you can build in a knowledge of how well the heat pump should work at low temperatures, or even monitor its performance ongoingly and switch over to the oil stove at the point where it doesn't make sense anymore from an economic point of view to run the heat pump. And the advantage is you're saving on energy costs when you can run the heat pump at slightly milder conditions, and then still take advantage of the resiliency that's provided by the oil burning stove when temperatures are really, really low. You've also got then 2 sources of heat, which increases resiliency in homes. And basically it's a win-win. And then, oh, by the way, bonus, you have air conditioning when it's really hot out, when the sun is low in the sky, and when you don't want to open the windows for various reasons, maybe because there's pollen or because there's wildfires, something like that. So this EcoSnap would like to be an easily deployable and affordable way to increase resiliency and still preserve the comfort that comes from an oil burning stove. So that's one of our grants that we're working on. The second one, and this is the one I'd really like some feedback on, is we've proposed to modularize the outdoor unit. And the genesis of this one was initially I had this vision of EcoSnap being able to be installed by a grandma, like a powerlifting grandma, maybe, but a grandma. And those outdoor units, if you want to hoist them up on a bracket, they can weigh 60 or so pounds. And so we had the idea that if we could break out the exterior unit into parts, each part could be kept under 30 pounds and it would be easier to set in place. But what I found was, while talking to folks in Alaska, they all said, that's great that you simplified the install, Diana, but what happens if something breaks? I'm in the middle of you know, rural Alaska, and do I have to throw the whole unit away? And we took that pretty seriously, and we came up with this idea of a modularized external unit, where you could pull the pieces due to our quick connect system and, transport them maybe on a plane back to the manufacturer, us, for service or replacement, and then swap them out and not have to remove the entire unit or throw it away. I'm playing around with ideas of whether upgradability would also be attractive here. Say a more efficient heat pump comes along, compressor comes along. Would it make sense to upgrade, or is that not an attractive thing? And so this is an idea that we're working on. We'll have a prototype ready by the spring, and I'd love to hear your thoughts on that. Another consequence of this, or perhaps opportunity, is we hope to snug the unit very close to the exterior wall, so that it is lower profile and more protected from heavy snow and weather. Phil, I took to heart what you said about serviceability and cleanability, I should say, and we'll design it so that you can get at the coils for cleaning from the sides by removing the panels. And then finally, we have a project with NREL Fairbanks that is also funded by the Department of Energy, where we're going to look at the ruggedness and resilience of the heat pump in cold climates. So starting with laboratory testing and looking at, are those connections really durable? Are they reliable under temperature cycling? And do they continue to perform over time? Because what we don't want to do is introduce something that is not sufficiently designed for your climate. We know the heat pump is, we want to make sure that the mounting and connection system is rugged and reliable. And this will allow next year for field demonstrations in 2 different climates in Alaska. We'll be asking for, we'll be recruiting installers of various skill levels to tell us what we've done wrong, what do we need to improve, and what could be made better. So we'll have a targeted solution specifically designed for Alaska. And that is what I have to offer. Let me know if you have any comments or questions. I've already learned a lot just from watching Phil's performance presentation, and I'd love to take your questions.
Thank you, Diana. I might start with 2 clarifying questions just to make sure I'm understanding a couple of the projects, and maybe others have the same question. For the first project, the thermostat integration, just to make sure I understand. So is the goal to essentially automate when the heat pump turns off and the Toyo stove turns on so that the homeowner isn't having to pay attention to the efficiency dropping?
Yeah, that's right. Because one thing is that the homeowner is not very transparent in the mini splits that are available today. What the performance is, we're actually working on that. We might go with just outdoor temperature as the switching point, but ideally we'd really like to build in a live measurement of the power consumption of the unit and switch over to the oil stove when that power consumption starts to go up, and it's when it starts costing too much money. And the advantage there is the homeowner might be, they're busy, right? They have their lives to live. They may not switch over at the right time for them economically, or they might not go to the heat pump soon enough so that they get the full advantages of using a heat pump when it makes sense.
Awesome. Thank you. And then my second question for your modular, your second project, the modularly one's focused on breaking it into pieces. You posed the question about upgradability, and I thought it might be helpful for folks to be able to think about that, to know what the expected general lifespan of a unit is, or what that range is.
So I'm told that if mini split heat pumps are installed correctly, they are extremely reliable and should last 20 years easily. And so almost by design, what we hope to do is make it so that it never does need to be serviced at all, right? But in terms of upgradability, I'd say new technologies come along pretty frequently. Like, there's a lot of work going on, especially on cold climate performance, that may allow for better efficiency and better performing units in every 5 years, I would say. Phil, I'm looking at you. I'd love to hear your thoughts on that since you are the cold climate mini split expert here. But I could see better technologies being available on a regular basis. So the question would be, is that attractive?
Yeah, I wanted to go back to it, that your Toyo stove heat
Mhm.
pump issue, which was something I brought up earlier with you.
I believe you were the one who suggested it.
Yeah, and interesting, that log house with that little mini split underneath the overhang there. What happens for her is at some point when it's fairly cold out, and she's just about maxing out the little heat pump, that it'll go into when the heat pump goes into defrost mode, it wants to push basically room air, maybe a little bit cooler air.
Right.
And the Toyo would sense that cooling for that short period of time during the defrost, and the Toyo would come on, which not a big deal, except that now the heat pump sensing the load is dropped, and so the heat pump throttles down, and then the Toyo's going, well, I'm not happy, or I could go a little higher, and so the Toyo cranks up a little bit more, and the heat pump cranks down, and it's like, no, I want the heat pump to do everything it can, and then let the Toyo, make up the difference. And that was the discussion we had with Diana, and she was fortunate enough to get some money to look at this issue. It's
Right.
not huge. It's not the end of the world, but if you're really trying to maximize your heat pump use and, save on burning oil, that's just a little problem, because they both have a big deadband between turning on and off. And so when one's at the tail end of one, anyhow, I'm looking forward to your solution.
Well, we're working with a company called Flare, and they have a lot of experience with controllers for hybrid solutions in New England. And so we'll definitely be, testing out the control algorithm and stuff like that. And one thing I want to assure people is that whatever system we introduce, it will always be overrideable. So if your heat pump breaks and you need your oil stove, your Toyo stove, you will always be able to disable the lockout. So we'll design it to be a fail-safe.
And your other question was?
I think the question was around how long these things are supposed to last. And I saw Ingemar put in there that they put in 16 Panasonics and they're all working after 8 years. So, and I honestly think ductless mini splits are more reliable than central heat pumps, and they perform better too, because they've got these inverter compressors, and they're so sort of like compact and everything that if you maintain them well, they should honestly just last forever. Well, maybe not forever.
Well, I suspect because there is some moving parts, the harder you work them, the shorter the life of that compressor may be, though age up, always plays in there. So no, I expect like that little heat pump in that log house, because it just runs full speed for 6 months out of the year.
Yeah.
It may not last as long as one that's operating on a more efficient house, but we'll see.
So, Alyssa, I'm looking at your question there. The answer is I'm not sure about the installers and what process they would need. And perhaps that goes to the question somebody else had asked about how do we get people qualified and interested in being installers. I was just talking to one of the utilities the other day, and the rebates are written around the idea that the manufacturer is the one who says this is a qualified installer. Because EcoSnap doesn't require handling of refrigerant, it would be up to us to have a program by which we train and qualify people to install these units. But our ideal is really to have videos and training materials that make it so clear the way that it is installed, and to design it to be as intuitive as possible. So I don't know if I know the answer to the question about code requirements. I don't think that the codes that I've seen in Alaska address this at all, address the need to have a HVAC technician to install these things.
And I'll just rephrase, I'll repeat the question for folks listening to the recording, and to make sure Phil knows it if he wants to chime in. The bulk of the question from Melissa was, does the EcoSnap tech already have approval, Alaska approval for installers or builders to use this process instead? And that was also kind of tied into Mark's question, which I think is still relevant and would love Phil's input on, about any tips or how to encourage HVAC folks to become heat pump installers.
You know, I think there's two worlds. There's the heat pump installer. You know, to handle refrigerants, you need your EPA refrigerant card, which you can study up, you know, online and take an online test. You can get your fancy little card. I think at some point it gets down to, when are you required to have a mechanical administrator be part of this project, you know, to install a heating system or whatnot. Technically, you're supposed to have, unless you're in the rural Alaska, you know, somebody with a mechanical administrator's license overseeing project. I mean, in theory, that could go for a Toyo stove. You know, you know, anybody but a homeowner or a mechanical administrator install a Toyo stove? Nobody's challenged that, so it's kind of gone unregistered. And whether or not that'd be true for heat pumps, because the installation process is just mostly work. Other than the final, you know, setting a, you know, vacuuming out the lines and charging the system, everything else is just work, just cutting holes, running lines, and just physical work. I think with the issue, so I think getting installers trained up that basically follow the instructions and install a system is not all that complicated. Now, to start troubleshooting units and dealing with error codes and problems, I think that's kind of the next level of the heat pump world. But until we get them installed, we don't need them troubleshooted.
So Phil, I want to comment on that, because we hear that all the time from everybody, is why are these so difficult to understand and diagnose? Why don't they make them more transparent to both the homeowner and anybody who would want to service them? And there are people who are working on that, including, we're trying to Trojan horse a little bit of that under these grants, like just surreptitiously do a little bit of work to make them more communicative through these controllers. But I don't understand why the manufacturers all designed them to be so opaque. Like, I mean, even when I love my mini split, I'm like, what is it doing? Is it working right? I have no idea, right? And that's got to change. We think that there's a real opportunity there.
Right. Homeowners should be able to see what all of those, you know, sensors are doing, whether or not they're in, you know, performance, because, you know, service tech can go there and just like your car can plug in their little fancy gizmo and read all the codes and see which sensor is out of whack or what's going on. And yeah, that should be just simple. Other than manufacturers didn't want to share that information with anybody but their certified techs.
And I think that ties in a little bit to Alyssa's comment in the chat about making sure people have knowledge of the units in the area that they're installed, like, you know, some sort of paid technician position for local residents in partnership with these big installations, which I've heard that Sustainable Southeast Partnership is working with Southeast Conference on some of these types of trainings. I think it's still in the early stages, but that is heartening to hear they're thinking about, you know, how to maintain in remote areas. Yeah.
The question from Robin, are you asking the power requirements? All ours are 115 volt units, so they can be plugged into a normal outlet. Having said that, we will be measuring current and power consumption as temperatures go really low. And if we can't manage to run on 115 volts when it gets very, very cold, we may make a decision to have one that's directly wired to the panel. And that would be a 220.
And I also want to chime in, Damien asked about, Damien Hill shared the price per kilowatt hour versus gallon of heating oil. And I'm going to drop in the chat. Analysis North has done this pretty cool calculator. So that can give you a sort of base, analysis look at how those economics pencil out for different areas and different electricity costs. But if you guys know of any other tools too, please share.
If you really want to go simple, down in Seward, and if you play with that heat pump calculator, it'll come up with about the same. For milder climates like Seward, it takes about 12 kilowatts of electricity to equal 1 gallon of oil over the season. Really cold months take more, warmer months use a little less, but 12 for the very efficient mini splits, it's pretty good. Once you get in colder climates or larger systems, maybe it's 14 kilowatts. So if you're paying 20 cents a kilowatt for electricity times 14, that's $202.80 a gallon equivalent. So if you're paying significantly more for oil, that's your savings. So crude, but at least gets you in the ballpark.
That's good. Those are good numbers. Mark, I want to comment on your question. Oh, sorry, go ahead.
I'm looking at this. So you're thinking like 14 kilowatt hours when it's starting to get cold. So
and it could be 16 when it gets real cold.
Okay. So I'm really interested in the hybrid system in the warmer months. But at zero, I'm burning about 5 gallons of heating oil a day between the Toyo hydronic and then the Toyo hot water heater system. So yeah, I'm just running numbers in my head. I'm looking at like $12.60 a gallon. All right, thank you.
Mark, I'd like to comment on your question. I don't have an answer to it. I suppose everybody would like the answer to how do we get more people into the trades that we desperately need. But I just want to share what I know from Colorado. So there are traditional HVAC installers, and they'll reluctantly do heat pumps or heat pump water heaters. And they don't really like to do heat pumps because they're unfamiliar, both to the installer and to the homeowner. And they're worried that they're going to get callbacks, and it's just riskier, and so they don't want to do it. But what we've seen here in Colorado is that several HVAC companies have sprung up that are heat pump only. Their mission is only to install heat pumps. And I imagine that they have to walk away from jobs sometimes where the homeowner doesn't want a heat pump or it's not the right solution, but they're committed to the transition. And I don't know if you've seen anything like that in Alaska, but that's one thing is, if somebody has a mission that we deserve better technologies, there may be HVAC installers who will take it on, but it has to be somebody who wants to learn something new, and that's not easy for most humans.
Totally. And is incentivized to do that learning, whether
Right.
through, business growth or
That's right.
training. And so I think, those are all really important things to consider. There are so many good things happening in the chat. I want to make sure these last 4 minutes we have time for folks to share any updates. But I will check with Dr. Fisler and Phil about sharing their contact information with the group for any follow-up conversations. Just transitioning over to updates. Unless Diana and Phil, do you guys have anything else you want to share at the end?
I just liked Steve's comment that Juneau has a heat pump only company. I didn't know that. That's awesome.
That is Very cool. Okay, so yes, transitioning over to updates. If you guys either want to drop them in the chat or raise your hand, come off mute, feel free. I can kind of start a Rural Energy Conference coming up next week. Really excited. Hope to see a lot of you guys there.
I'll be there.
Awesome. And we have our training coordinator for our People in Power program going to be on a panel on, I believe, Thursday, with some folks talking about overcoming challenges of scale, which I think is related to this issue and a lot of the other issues we talk about in Alaska. So hope you guys can join. And I think also heat pump related, I can share. I don't see him on the call, but a professor at UAA, Professor Gaitu, is involved in the LG consortium that's starting a heat pump lab at UAA here in Anchorage. So I think that's going to be becoming online this fall was the original plan. So that's an exciting update. And then I think in recent conversations, I talked to David Ruff over at UAS, who had an update about their CDL program. I don't know if you're on the line, David, and want to share anything.
Yeah, I am. Can you hear me?
Yes.
Excellent. First off, thank you, Diana and Phil and Jenny, for throwing this together. Very informative. I'm talking to you here from University of Alaska Southeast in Juneau, and we are trying to put together a CDL training program. We know that there's a definite need for commercially licensed drivers, just like there's a need for heat pump installers. So that's kind of the thing we're always looking at, is trying to find ways to meet market demand. And so, yeah, that's something we're putting together here and hoping to have students enrolled by January of 25. So we're working on that, trying to meet that need.
Awesome. Thank you, David. I'm watching that program closely. That'll be exciting. And Robin Gilchrist shared that UAS had a heat pump installer training last spring and plan to continue to create additional training in the late fall and spring. That is great. I was hoping to put Colin Stewart on the spot. I saw he had joined earlier from AvTech, but looks like he hopped off. But they also incorporate some training in their programs over there. We'll try to get some info maybe to share in a follow-up about timing for you guys all who are interested. And that pretty much puts us at time. Thank you so much for the great conversation. I will follow up with the recording and meeting minutes and contact information. Oh, and Sean jumped in to share that Chugach Electric offers a heat pump incentive. And our next meeting is tentatively scheduled for December 4th at 11 a.m. virtually again. Topic TBD. Feel free to reach out if you have one top of mind that you want us to put some discussion together around. And another update from Rosa, Cold Climate Housing Research is launching a weatherization installer badges program November 1st. That sounds exciting. I want to learn more about the badges. And so, yeah, please send me more information about your updates. I'll make sure to share them in the email follow-up as well. And Mark shared that AvTech did a CO2 heat pump training last spring. Thank you, Mark. So yeah, like I said, thank you so much again for joining and for the great discussion. And we hope to see you guys soon, whether virtually or in person in Fairbanks or somewhere else. Take care, y'all.